Assalamu alaikum students. In this video, we are going to see the JK flip-flop implementation on breadboard. To understand the functioning, let's first see the circuit diagram of JK flip-flop. Here is the circuit diagram of JK flip-flop using NOR gates. We can see we have an input J and another input K and a clock signal as we are making flip-flop, or you may have enable signal. I have two AND gates and two NOR gates. On output side I have first output Q bar and the second output is Q, which is opposite to JK flip-flop using NAND gate, because in JK flip-flop using NAND gate we have output Q at first and the output Q bar at next. So let's see these component on circuit maker. This is enable signal input, this is J input and this is K input. This is my AND gate IC, this is my NOR gate IC, this is my output Q bar and it is my output Q. So let's see the functioning of the flip-flop. So now the circuit is running. So let's see the truth table of JK flip-flop. So from truth table we can see if we have enable signal 111 and the corresponding JK flip-flop, we will have this output accordingly. For example, if enable signal is 1, J is equal to 0, K is equal to 0, there will be no change, which means that what will I have output before pressing, I will have this same output after pressing or giving the input. So it is my enable signal, I press it to give 1 and leaves the two push button. If I do not press these two push button, it means there will be 0, and you can see there is no change on output. Now let's see another combination. If enable signal is 1, J is equal to 0 and K is equal to 1, Q will be 1 and Q bar will be 0, which is reset case. So enable signal will be 1. I will not press this push button, which means J will be 0, and I will press this push button, which makes K is equal to 1. So the output will be Q bar is equal to 1 and Q is equal to 0, as it is on truth table. So the next combination is enable signal is equal to 1, J is equal to 1 and K is equal to 0. So the Q will be 0 and Q bar will be 1, which is set case. At this moment I have Q bar is equal to 1, Q is equal to 0. So enable signal should be 1, K should be 0 and J should be 1. So let's see the effect on output. So my Q become 1 and Q bar becomes 0, which is set case as it is on truth table. Let's see the next combination, which is E is equal to 1, J is equal to 1, K is equal to 1. So it is the toggle case. It means if I have 1 0 before pressing the input, then after pressing 1 1 I should have 0 1. Before seeing the practical implementation of toggle case on breadboard, I want to show you why I am not taking the enable signal is equal to 0, because when I take enable signal is equal to 0, there is no change on output on giving any input. So I will have whole case for all the cases in which I will have enable signal is equal to 0. Let's see the implementation of toggle case on breadboard. Right now I have q is equal to 1 and q bar is equal to 0. For toggle case, I should have e is equal to 1, j is equal to 1, and k is equal to 1. When I press e is equal to 1, j is equal to 1, and k is equal to 1, my output has become dim. Actually, the toggling is happening so fast that we cannot see with naked eyes. So I will have to leave the enable signal so that it could store the output while toggling is happening. Let's leave the enable signal and again press. I have released the enable signal. Now I am pressing, releasing, 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 pressing, releasing. So this was the implementation of JK flip flop. Let's see this implementation on circuit maker. But before going to implement this combination 1 through 4, I would like to show you why I am now using enable signal is equal to 0. Because when I use enable signal is equal to 0, the output remains unchanged on changing input. For example, if I change G is equal to 1 and K is equal to 0, the output will remain same. And if I change J to J is equal to 1 and K is equal to 1, the output will remain same. So when enable signal is equal to 0, the output will always remain same. Now to get the desired output, we need to make the enable signal is equal to 1. Now let's check this combination one by one. The first combination is E is equal to 1, J is equal to 0, K is equal to 0. So when J is equal to 0, K is equal to 0, they will be same, output means no change. Now the next combination is J is equal to 0, K is equal to 1, which is reset case. So J is equal to 0 and K is equal to 1. The output is Q bar is equal to 1 and Q is equal to 0, as it is in the table. The next combination is J is equal to 1, K is equal to 0, which is set case. The output is Q bar is equal to 0, Q is equal to 1, as it is in truth table. The last combination is the toggle case, and it happens when J is equal to 1, K is equal to 1. As you can see, the toggling happening very fast. To make it clear, I make the simulation slow. Now you can see the toggling happening. But in practical implementation, we make the enable signal is equal to 0 to make the toggling clear. So if I make the enable signal is equal to 0, I can see the toggling as we done in our practical implementation. So it is the implementation of JK flip-flop using NOR gates.